Video, I will be recording the entire 2015 AP Calculus AB exam free response questions. All right, question number 1 says the rate at which rainwater flows into a drain pipe is modeled by the function r, where r of t equals 20 sine of t squared over 35 cubic feet per hour, where t is measured in hours and t is between 0 and 8. The pipe is partially blocked, allowing water to drain out of the other end of the pipe at a rate modeled by d of t, is negative 0.04 t cubed plus 0.4 t squared plus 0.96 t cubic feet per hour between 0 and 8 again. There are cubic feet of water in the pipe at time t equals 0. So as we've talked about, we always underline this is our initial value. So this is saying that the amount, so I'll call it amount, at time 0 is equal to 30. All right, and A is just going to be the amount coming in minus the amount coming out, right? So for part A, it says how many cubic feet of rainwater flow into the pipe during the 8-hour time interval 0 to 8. So we're only talking about the amount that's coming into the pipe, which is our R of t. So what we're going to do is, since this was in cubic feet per hour, we need to integrate to get cubic feet. So we're going to say from 0 to 8, R of t dt. And I don't waste time writing out the function or anything. I just put it in like that. Now I've already put this into my graphing calculator under y1. All right, so I'm going to integrate y1. So I'm going to do math, 9, vars, y vars, function y1. And I'm going to integrate that from x equals 0 to x equals 8. Or in this case, t equals 0 to 8, right? And I hit enter, and I get 76.570. All right, so that is my answer. All right, what it is what the units are is just in gallons, or not gallons, what am I talking about? Cubic feet. It would make sense that it's gallons if it's water, but that's okay. All right, so part B, is the amount of water in the pipe increasing or decreasing at time t equals 3 hours? Okay, so we need to talk about the r minus d. So we need to figure out what's happening, the rate that it's coming in at time 3, and the rate that it's leaving at time 3. So we need to compare those. So we're finding r of 3 and also d of 3. All right, so when I do that, I go to my calculator, and you can do this a couple different ways. So you could do vars, y vars, function y1, and you can actually do of 3. And then you can do minus, and I actually have the other one in as y vars, function y2. And I can say y2 of 3. And I don't even know if we've actually talked about that in class, that you can do that. It's kind of nice. And you end up getting negative 0.314. Okay, so what we need to decide is, is more water coming in or is more water coming out? And that's what we just did. We saw that it's a negative amount, meaning that more water is leaving than is coming in, right? So the amount of water in the pipe is decreasing. So you could say like R of 3 is bigger than, not bigger, it's smaller, right? Is smaller than D of 3. So the amount of water is decreasing at time t equals 3, which is in hours. All right, and then C, it says at what time between 0 and 8 is the amount of water in the pipe at a minimum? Justify your answer. Okay, so if we're talking about the amount of water in the pipe, okay, it's not totally equal to this r minus d. I really should say it's the integral of r minus d, and then we add on that initial amount, which was 30, right? So I should set that up. I should say, okay, well, for the first t hours, we're going to have our amount that went into the tank, I'll use x's here, minus the amount that left the tank. All right, but I also have that initial amount, which is 30. So I'm going to say plus 30. And all of that equals your amount at time t. Okay, so I'm writing it out very formally. All right, now remember, we've talked about that before. If I'm integrating, let's say a prime to simplify it, from 0 to 30, not 30, t. What we would get would be a of t, really should say x here, a of t minus a of 0, and the a of 0 is the 30. That's why I'm adding 30 to this integral. Okay, it's coming from the fundamental theorem of calculus. All right, it's like saying if you start with 30 and how much have you gained in those first 8 hours, you still had 30 originally in there. Okay, so when I find this, so I'm going to find my a prime of t, which is going to be the derivative of all of this. So if I have the derivative of an integral and then the derivative of a number, I end up getting r of t minus d of t. Okay? So I want to find when that's equal to 0. In other words, where is r of t equal to d of t? And since I have both of those in for y1 and y2, I just go to my calculator and I find their intersection point. So I'm going to make sure my window is from 0 to 8 just so I don't mess myself up and pick a number that's bigger than 8. And I do I graph. And then I find where they intersect each other. All right, now I'm not seeing a lot of this graph. I'm seeing one, I guess. I guess that's good. All right, so I'm going to do second trace. I was going to adjust the window, but I didn't need to, did I? Intersect. And I go right to where my intersection point is and do enter, enter, enter. So I get 3.2716, blah, blah, blah. So I'm going to do second quit. I hit X, and I store it. So I'm storing it as alpha A. And I'm going to write that down. So I have t is equal to 3.27165 something. All right, which I'm going to say let A equal 3.27165 something. So I'm going to store it as my A. All right, and so let's look at the graph again. Okay, were there any other intersection points? And there actually was. It was right here at 0. So if you plug in 0 to both of these functions, right? So sine of 0 we know is 0, and then a polynomial where we don't have a constant term, that's also equal to 0 when you plug in x equals 0. So it was also at time t equals 0. So don't forget that one. And then typically I do a little test. I say, okay, I'm on the interval 0 to 8. I'm thinking about a prime. I have critical values at 0, but also 3.27165, right? And I'm going to test in each interval. So if I test, let's say, 1 into a prime, that's r of t minus d of t. So what is r of 1 minus d of 1? We would need to find that. So I'll pull up my, I'm not going to put this all in again. I'm doing second enter clear until I get that y1 minus y2. So I'm going to plug in 1 for these. So I get a negative amount, all right? But if I do second enter and I plug in like 4, I get a positive amount. So that means that A was going down and then it was going up, so that indeed is a minimum. So we need to justify our answer somehow. So we can do that. So we don't just leave the chart, we have to say what's happening. And we would say something about a prime is less than 0 on 0 to 3.27 whatever, and a prime is greater than 0 on the other part. Therefore, there is a minimum at t equals 3.272 hours. Okay, and that, I believe, would be enough justification. Now, what the AP scoring guide likes to do, and you will see this from time to time, is they'll say t and then amount at time t, and they actually plug those numbers in. Now, you can tell it's a minimum based on that, right? I don't have to check my endpoints. I don't have to check 0 and 8 because I know that my function was going down and then it was going back up, right? But they like to try these. They like to plug them in. So you might see something like this. So when you plug in 0 into a of t, which was up here, right, you'd have 0 to 0, which gives you 0, and you'd end up getting 30. All right, and then when you plug in 3.272, or a, which you've stored, you would end up getting 27.965, and when you plug in 8, you'd get 48.544. But personally, I don't think that you really need to do that, because as long as you've justified like this, you're good. You've said that there's a minimum, right? You've even checked the endpoints. You know that the endpoints are higher than that is. Now, if you had something where it went back down, then yeah, you should plug in those values and find the endpoints. But I think that was a little bit extra in this case. All right, and then part D, it says the pipe can hold 50 cubic feet of water before overflowing. For time t is greater than 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Write, but do not solve an equation involving one or more integrals that gives the time w when the pipe will begin to overflow. So again, it has to do with our 30, right? Plus, and it's talking about the time w. So I'm going to, instead of writing t, I'm going to write from 0 to w. And then I'm going to do my r of x minus d of x, or r of t minus d of t. And I want for all of that to equal 50. Okay, that would be perfectly fine. You don't have to subtract the 30 over or anything. You just set it up just like that. So the scoring guide for question 1, you get 2 points. 1 point for the integrand, so the r of t, 1 point for your answer, which is the 76.570. For part B, you get 1 point for considering what r of 3 and d of 3 are, and deciding, well, r of t is smaller than d of 3, so that's going to be your answer with reason, so a point there. Part C, the amount of water between 0 and 8 is 30 plus, we did this. So considering where r of t minus d of t is equal to 0. So we took the derivative of this, set it equal. 1 point for your answer and 1 point for your justification. And then part D, you get 1 point for the integral part. You get 1 point for your entire equation. All right. Number 2, it says let f and g be the functions defined by f of x equals 1 plus x plus e to the x squared minus 2x, and g of x be x to the fourth minus 6.5x squared plus 6x plus 2. Let R and S be the two regions enclosed by the graphs of f and g as shown in the figure above. Find the sum of the areas of R and S. Okay, so we've done lots of area and volume problems, and I've told you that over the last few years, they've gotten a lot harder. And you guys can see this is finding 2 areas, not just 1 area. So we have to add them together. All right, so what we're going to do is our f of x, let's see, I have these graphed. Our f of x is our first one, so let's look and see which one that is. It's an e to the x equation. So when I hit graph, you can kind of tell that it's that curve right here. So this is going to be the f of x equation, and then the other one is going to be our g of x equation. All right, so when I find the sum of the areas, I'm going to need to find where they're intersecting. So I'm going to go ahead and graph them as I have both of them in my calculator already. Graph both of those. And I'm going to find their intersection point. Okay, so they have 3 intersection points. 2 of them are already given to us. So we had 0, 2 already, and we had the point 2, 4 already. Do you guys see? 0, 2, and 2, 4. So we need to find this intersection point right in the middle. So I do second trace intersect. I'm way up there. So I'm looking at my y values. I want to get kind of close to 0. All right, there we go. Enter, enter, enter. So I have x equals 1.0328 and y is 2.4011. All right, so I'm going to go back to my main screen. I'm going to hit x, and I'm going to store it as alpha a. And then I'm going to hit y, so alpha y, and I'm going to store it as alpha b. Okay, just so I have both of those. All right, and I'm going to write that I did that on my paper. Now, you also have to write what you did to get that point. What we did is we set f of x equal to g of x, right, to find the intersection points. And when we did that, we got that x intersects at 0, 1.03283 something, and 2. Okay. So we're going to let, and I usually kind of write it here, so 1.032 ... comma 2.4011 ... and I circle A and B. I'm like, okay, I've stored these as A and B. So I'm going to let A equal 1.03283 and B is equal to 2.4011, just in case I need those values, which I know I need the A, but I may not need the B. But sometimes you might need it for one of the volume ones. All right, so if I'm finding the sum of the areas of region R, I'm going to say my area, total area. So for R, it's going to be top minus bottom, so it's G of X, the red line, minus F of X. And that goes from 0 to A. And then the other one is from A to 2, and that would be F of X minus G of X. And I put this into my calculator, and I do math 9. And I can just say, okay, I need my y vars. So vars, y vars function, I believe it was y2 first, minus vars, y vars function, y1. And my x goes from 0 to A, and I can get that answer. And then I could add it, you can actually do this all together, to math 9, vars, y vars function, now the f of x is on top, minus vars, y vars function, y2. And now that's going to go from A to 2. And we put it all in together, and we get an answer of oops, maybe not. I thought it was going to be 2.004. I did this earlier. So did I mess it up somewhere? So let's see, G of X minus F of X from 0 to A, and then A to 2. Oh, you know what? I'm using Y1 and Y2, and it's not Y1 and Y2. It is Y3 and Y4. So I forgot I had the first question in there as well. So we're going to do Y4 minus vars, Y vars function, Y3, and then the same thing here, but Y3 minus Y4. All right. So yeah, 2.004 is the answer. And you could find each one individually. I actually found each one individually before, and I had like 0.9974 plus 1.0069. So you can do that if you want, or you can do it all together like I did. All right, and then region S is the base of a solid whose cross-sections perpendicular to the x-axis are squares. Okay, so let's kind of clear this out a little bit. All right, so I have cross-sections perpendicular to the x-axis. So I'm making my chops like this, and off of each of these chops I have a square shape. So I have this side and I have another side, okay? So the side ends up being the top curve, which was our f of x, minus the bottom curve, which was our g of x. So my side, and you can write that out, side, or s, is equal to f of x minus g of x. So that's one side of the square. So when I'm finding a volume, I'm always integrating an area. So I'm integrating the area of a square, which is going to be side squared. And I'm doing that from my a value to my 2. Okay, so I went ahead and found that, and it ends up being 1.283. So you can do math 9, you can put all that in. You do get 1.283. And then the last part, it says, let h be the vertical distance between the graphs of f and g in region S. Well, we already did that. That's f of x minus g of x. Find the rate at which h changes. So we're writing h of x is equal to the top minus the bottom. So the rate, that means h prime, is going to be f prime of x minus g prime of x. And we want to find it when x is equal to 1.8. All right, so we want to find h prime of 1.8, and it's going to end up being f prime of 1.8 minus g prime of 1.8. And if you look at your functions, f of x and g of x, not really that fun to take the derivative of. You can. It's not terrible. But if we have our calculator, I would just use my calculator, right? So I'm going to go to my main screen, and I'm going to do math 8, which is n deriv. And I'm going to find the derivative of f at 1.8. So I'm going to do vars y vars function, and like I said, this was in for y3. So I'm taking the derivative of y3 at x equals 1.8. Okay, and then I could do minus, and I could do my other one as well. So math 8 n deriv vars y vars function y4, and again evaluated at x equals 1.8, right? So I put all of that in. Now your calculator might actually look like, when you're putting in n deriv, it might look like d, and you'd put in an x, and then it's going to say, you know, something evaluated at x equals. So you're going to put in y3 like I had at x equals 1.8 to get that. So it might look a little bit different when you're doing this, but regardless, you should get the same answer, which is negative 3.812. Okay, so the last thing we'll look at is the scoring for question number 1. So the scoring, it says the graphs of y and g intersect in the first quadrants at the points 0, 2, 2, 4, and also a, comma, b. All right, did we actually need to list the points? We did not. Okay, so the area ends up being, so you get 1 point for your limits, 0 to a and a to 2. You get 2 points for the integrands, which are g of x minus f of x and f of x minus g of x. And you get 1 point for your answer, which is 2.004. For part B, you get 1 point for your integrand, which is f of x minus g of x squared. You get 1 point for the answer. You get, for part C, 1 point for considering that h prime is f prime of x minus g of prime of x, I guess. And then 1 point for your answer.